This is an optional video on Lesson 6 classwork. I've made it so that you can skip ahead if you'd like. I would recommend that you look at number 10 if you don't look at any of the other ones on this video. So, number 1, the instructions are to use the absolute value equation to just answer the questions. So, vertex is at, if I set x plus 9 equal to 0, I would see that my vertex is at, my x value is negative 1, and my y value is, negative 9, and my y value is negative 1. It is a positive a value, so it opens up. Now, I need to look at this a value. Remember I said if you see a fraction, but the fraction has to have a numerator that's smaller than the denominator, well, the 5 is bigger than the 2. So this is actually greater than 1. 5 halves is 2 1/2. So in this case, my graph would end up being narrower. It would have a vertical stretch, so it would be narrower than the parent function. Number 2, here we have a vertex at 3 and negative 4. It opens up, a value is positive, and here the a value is greater than 1, so again this one would also be narrower and taller than the parent function. Number 3, the instructions here are to graph the absolute value function and state the vertex, and the translations to graph the function. The vertex for number 3 is negative 2, negative 5. That's where I like to start. I like to find the vertex and then go ahead and graph that. Negative 2, negative 5 is right here, so I've graphed the vertex. The translations, let's see, we've got 4/3 is greater than 1, so you know what, you don't even have to worry about that really, because if you just graph the slope from the vertex, then that's all you need to do. It opens up, so we can go up 4 and over 3. And on the other side, same thing. Just want to mirror it. And then just join those points. The translations that we want to note would be sorry, I'm looking at the wrong one. The slope is 4/3. It's a vertical stretch. Left 2 and down 5. And that's it. Number 4, pause the video and then come back to it and see if you got it right. This is what you should have gotten, the vertex 0, negative 3. It did reflect over the x-axis because the a is a negative 1, and the translation is down 3. Number 5, it asks us to write the equation and then state the domain and range. Even though these don't have arrows on the end, I tend to like to draw arrows on the ends, because if it stops right there, then that's a different domain and range than if it keeps going. So I just like to draw the arrows. The translation here is left 3 and down 2. So part of my equation I can go ahead and write x plus 3 in the bars, and then minus 2 on the outside of the bars. This is a negative slope, and it's a negative 1 slope, so I know that this is just negative 1, so I can just put a negative right there, and I don't have to put the 1 there. If you do, it wouldn't be wrong. The domain, it comes left to right. It comes from negative infinity and goes to positive infinity, going to the left. And then the range, if you start at the bottom, it's coming from negative infinity, and it stops at negative 2. We could also state that the slope is negative 1, a is negative 1, the vertex is negative 3, negative 2. They didn't ask us for that, but if you wanted to make a note of that, you could. All right, the next one, number 6, same thing. Put your arrows up here at the top. The equation, let's see, there's no left or right for the vertex. There is a down 2. So I can start my equation out and just leave a little bit of room for an A if there's going to be one. There was no left or right, so the x is in the absolute value bars by itself. I've got a -2 out here. Let's look at the slope. From this vertex, the next point that I can kind of see that's where the vertical and horizontal lines cross the line here is right there. So let's count 1, 2, 3, 4, 1. That is a +4 slope, so I've got a 4a equals 4, and that's the equation right there. Domain, I'm going to give you a piece of information that'll be important. Absolute value graphs, the domain is always all real numbers. The inverse of them wouldn't be, but we're just looking at the graphs. So the domain is always the same. Range, on the other hand, look at this where it comes from. It starts at -2, so that's a bracket, -2, and it goes to positive infinity from bottom to top. Okay, so then we start on our absolute value equations. And if you remember, we want to isolate what's in the bars. This is already isolated, so then we can make our two equations, take this out of the bars, make the two equations exactly the same on the left side. On the right side, one's positive and one is negative. And then solve for x. Subtract 2, multiply times 3, x equals 12. Subtract 2 here. Multiply 3 times -8, x equals -24. If you did check those, you would find out that they both work, they both check. So we're just going to go ahead and say that those are the two solutions to that equation. Number 8, the absolute value is not isolated. Let's look at what the absolute value is that we need to isolate. We need to make sure that this part right here is by itself. So we have it divided by 4. So we need to multiply times 4 on both sides. Keeping it in the absolute value, I isolate that, and then I can take it out. 3x plus 5 doesn't change. What's on the right does. So we have +4x, -4x. Now let's solve for x. I'm going to subtract 3x on both sides. 5 equals, that's 1x. So 5 equals x. Subtract 3x here. 5 equals -7x, divided by -7. Okay, so only one of these works, this one. When you go to check it, if we were to check this one, we would find out that it would not work. It would not check out. So this is the solution to that one. Number 9. Let's isolate what's in the absolute value symbol. Let's add 2x on both sides. Absolute value of 2x minus 5 equals 5x. Now I can take it out of the bars. Set it up equal to positive and negative. Okay, so let's subtract 2x. -5 equals 3x. Divide by 3. X equals -5/3. Subtract 2x here. -5 equals -7x. Divide by -7. Let me look and see. This one doesn't work when you plug it in. This one does. So again, you have to go and plug these in. I'm not going to take the time to do that in the video, but you would go plug it in for x and see if what you get on the left is equal to what you get on the right. Okay, number 10. This is the one I really wanted you to look at, just to show you that once I isolate the absolute value part, and I am going to highlight that one more time. So I need to isolate that part, which means I need to divide both sides by -8. -8 cancels here, and then I get the absolute value of 3 minus 8k equals -5. Because the absolute value of any number can never be a negative number, there is no solution to this equation. So that is the answer. If you have an absolute value equation and you end up, after you isolate the absolute value and you end up with a negative number over here, it cannot be worked. So there is no solution to that problem. And that is it for the classwork.